Exponential functions. We can use this expression to represent the exponential function, that is y equals b raised to x. Here you must be careful. B is a constant. X is the variable. X is the independent variable. Y is the dependent variable. X changes, Y changes correspondingly. B is constant. But when discussing the exponential function, we need to divide the expression into two situations. The first situation, b is a number which is greater than 1. The second situation, b is a number less than 1. But you need to know, for these two situations, b must be a positive number. That is to say, b greater than 0. Alright, this is the prerequisite for the two situations. Alright, so for this one, if b is greater than 1, it must be greater than 0. For this situation, b less than 1, simultaneously, b must satisfy this requirement, so we say b greater than 0, less than 1. Okay. Now, for this first situation, if b greater than 1, we can sketch the graph for this function. That is to say, the function is an increasing function. It comes from the second quadrant and in the first quadrant. Comes from quadrant 2 and in quadrant 1. This is increasing function, so this is the graph, but you must be careful. This is the point at which the exponential function must pass. Okay, so this point, we say it is 0, 1. This is x equals y equals 1. This is a straight line, all right? So for the exponential function, in the first situation, the graph is like this. Here, this point, the function must pass this point. Reversely, we can say this point must be on the graph of this function. Okay? But you must be careful. For this graph, the graph will not touch the x-axis forever. That is to say, the graph will extend in this direction, but will never touch the x-axis. We say it will approach x-axis, but never touch x-axis. So we say x-axis is the asymptote of this function. We can say there is no POI, point of intersection, between this graph and x-axis. Okay, let's move on to the second situation, b less than 1, simultaneously greater than 0. In this situation, the graph of this exponential function is a decreasing function. It comes, or we say it starts in quadrant 2 and in quadrant 1. Of course, the function also passes the point 0, 1. Or we can say this point must be on the graph of this function. For this graph, it will approach x-axis. We say approach, not touch. That is to say, the graph will not cross x-axis. There is no POI between this graph and x-axis. We say x-axis is also a asymptote for this function. From these two graphs, you can summarize the features of exponential function. X in the position of exponent, this is the independent variable, b is the base. It must be a constant. But we divide this function into two situations. This is the first situation, b greater than 1. This is the second situation, b greater than 0, less than 1. For these two situations, the graph of this function must pass the point 0, 1. For these two situations, x-axis is the asymptote for this graph and for this graph. In this situation, the exponential function is an increasing function. In this situation, the exponential function is a decreasing function. That's it.